Section 9.1 is on mathematical patterns. A sequence is an ordered list of numbers. Each of the numbers is called a term. The terms are represented by their position in the sequence. The first term is called a sub 1. It's really a with a subscript of 1, and we say that a sub 1. The fifth term would be a sub 5. A term can be referred to in general as a sub n, or the nth term in the sequence. An explicit formula describes the nth term of the sequence in terms of n. So for example, for the explicit formula, a sub n equals 3n, a sub 5 would be 3 times 5, put in n for 5 for n, 3 times 5, which is 15. Let's take a look at an example. A sequence has an explicit formula, a sub n equals n squared minus 10. What is a sub 8? So a sub 8 is going to take that formula and plug in 8 for n. So 8 squared minus 10, 64 minus 10, or a sub 8 is equal to 54. A recursive formula relates each term, a sub n, in the sequence to the term before it, a sub n minus 1. n minus 1 is the term before. So for example, in the sequence 52, 48, 44, 40, 36, and so on, each term after the first term is 4 less than the previous term. The recursive formula for this relationship would be a sub n equals a sub n minus 1 minus 4. This means that the nth term is equal to the term before it, which is a sub n minus 1 minus 4. Let's take a look at an example. Write a recursive definition for the sequence 1, 2, 6, 24, 120. So I want to take a look at this and kind of see what's going on. Well, as I go from 1 to 2, I notice that I'm multiplying by 2. As I go from 2 to 6, I notice I'm multiplying by 3. 6 to 4, I multiply by 4. And from 24 to 120, I'm multiplying by 5. I also notice that this number that I'm multiplying by is the position number of the term. So this is the second term. This would be a sub 2. This is a sub 3. This is a sub 4. And a sub 5. So I think I can write this as a sub n equals the position number times the previous one. So 2 is going to be equal to its second position, which is n, times the number previous to that. Let's just see if that works. Let's pick a random one here. So let's try 24. Okay, so is 24, that would be a sub 4. Is that equal to 4 times the previous term, a sub 3, which is n minus 1? Yes, it is. So that would be my recursive definition for that sequence. Next example says write an explicit formula for the sequence 1, 4, 9, 6, and so on, and then find the 10th term. So the formula for this is pretty obvious. These are all perfect squares. So a sub n is equal to n squared. So whatever, this is a sub 1, and that's 1 squared. This is a sub 2, and that's 2 squared, and so on. So now I need to find the 10th term, so that's going to be a sub 10, or 10 squared, which is 100. Notice the difference between the two formulas. An explicit formula defines the sequence in terms of n, so the example right above here. A recursive formula, or recursive definition, defines the sequence in terms of n minus 1. It's always based on the previous term. And our last example here says find the 8th term of the sequence 1/2, 1/4, 1/8, 1/16, 1/32. As you notice, each of these is getting cut in half. They're each getting smaller. But one thing I notice is that the denominator, these are all powers of 2. This is 2 to the 1. This is 2 to the 2. 8 is 2 to the 3. And those are in the positions 1, 2, and 3, and so on. So it seems to me that the definition for this would be a sub n equals 1 over 2 to the n, where n is the position each of them is. So in that case, finding the 8th term, a sub 8, would be 1 over 2 to the 8th, or 1 over 256. So in this section, we took a look at some mathematical patterns, explicit formulas and recursive formulas, and how to find the nth term of a given sequence.